Okay, we're asked to consider a spherical concave mirror with a focal length of 20 centimeters, and we're to find the nature, size and location of the image formed by a 6 centimeter tall object placed 15 centimeters in front of the mirror. Now, just a reminder, first of all, that your textbook uses the real is positive convention, so all distances are measured from the mirror. Distances of real objects and images are positive, and distances of virtual objects and images are negative. And a consequence of this is that magnification is given by minus the image distance over the object distance. And we'll need the magnification to calculate the size of the object, and we will need another formula, which is 1 over p plus 1 over q equals 1 over f, in order to determine the location of the image. In fact, we can do the problem just using those formulae, but for practice I'll draw the ray diagram. Okay, so let's do the ray diagram. First, I'll draw a principal axis, then I will draw the position of the mirror, and then I'll indicate that it's a concave mirror by showing that it's surfaced on the rear and the left-hand side, the concave side, is shiny. I'll indicate my center of curvature and therefore my focus, and we're given the focal length being 20 centimeters. Therefore the radius of curvature is 40 centimeters. We're told that the object is placed 15 centimeters in front of the mirror and that it's 6 centimeters high. So that is almost to scale, but probably not quite. Alright, so let's draw in the rays and see what the image would be like. So first of all, we can draw a ray from the center, which passes the top of the object and is reflected at the mirror, and because it's from the center, it will be reflected back along its own path. Okay, so it will appear as if it originated behind the mirror. Secondly, we can draw a ray which is parallel to the optic axis, and such a ray will be reflected back through the focus. And will therefore appear to have originated from behind the mirror. So we're going to end up with a virtual image which is upright, formed behind the mirror. And the reason we can make this sketch easily is that the distances are convenient. But we didn't actually need to make the sketch. So we can calculate what we need to know directly. So first of all, we could use the formula 1 over p plus 1 over q equals 1 over f, where p is the object distance, q is the image distance, and f is the focal distance. So we know f and we know p, and we want q. So we can subtract 1 over p from both sides. And we can invert both sides, but first we need to remember to put a bracket around that, and that will give us that the image distance is 1 over f, minus 1 over p. So we can plug the numbers directly into a calculator, and because p we will see as p is smaller than f, 1 over p is greater than 1 over f, so we are going to get a negative number, and when we work that out we will find that the number we get is equal to minus 60 centimeters. So the image is formed 60 centimeters behind the lens, and it is the minus that tells us it is a virtual image. The other thing we would like to know is how high the image is. We actually know that the object has a height of 6 centimeters, and we also know that magnification is given by minus q over p, which in this case is minus 60, which is 60, divided by p, which is 15. So the magnification is 4. Magnification is how much bigger an image is than the object. So the height of the image, h, is equal to 4 times the height of the object, which is 6 centimeters. So the height is going to be 24 centimeters. Well, I'm running out of space, but please never leave your answers in these kinds of forms, because if a professor using a different sign convention was to mark it, they might not know what you meant. So let's summarize. And the nature, size and location of the image. The nature, it is a virtual image. (24 centimeters high). (60 centimeters behind the mirror). Okay, sorry about running out of space. And just to make sure that the person marking it knows where your final answer is, make it very clear to them. Okay, and we're done.